Good morning, students.
Good morning, ma'am.
How are you all?
Fine,
Fine, ma'am.
ma'am.
So, students, today we are going to discuss a very interesting topic. But before going to start that particular topic, I will narrate a story in front of you and then I will ask a question. If you know the answers, just raise your hands, don't give me collective answer. So, students, one day there was a big trouble at the power plant. The chief Vikram was worried about that trouble. The lights were flickering all around just because one component of that power plant, that is known as power pacer, was not working well. So Vikram's helper, that is Sham and Ram, has to do work on it. They have to identify that what type of connections are connected in the particular component, that that component is not working properly, so they had to do work on it. So they had decided and noticed as well that what kind of connections are arranged in that component. Then that component start working properly. Now students, tell me what type of arrangements did Ram and Sham has arranged there? So students, today we are going to discuss a very interesting topic and the name of the topic is series and parallel circuits. So before going to start this topic, I will introduce the definition of resistance in front of you and then you have to write down the definition of that on your notebooks. So what is resistance? It is the opposition offered by the conductor to the flow of current. So students, the resistance is the opposition offered by the conductor to the flow of current. So the resistance is combined in two ways. Those ways are two ways of combining resistances and those are series combination and parallel combination. Parallel combination. So students, firstly we will do about the series combination. So before doing that, I will show you the model of series circuit and you have to identify by which part it is made up of. So this is the series circuit. We have three bulbs here. So in this connection we have the switch here. Here is the battery. Very good. And the current is going to be flow through these three bulbs simultaneously. Okay. So we will see here which quantity is going to be vary here or which is stable. So when we switch on the button, the current will start to flow through it. That current will move through these three bulbs simultaneously and then go back to the battery. Just because we have switched on the battery, the current will start flowing and the bulbs will glow here. One student come and just switch on the button. Now what do you have observed here?
बल्ब ग्लो कर गए थे ना साथ ही में.
Yes, sit down. The bulbs start to glow simultaneously as we have switched on the button here. So this type of circuit is known as series circuit, in which all the bulbs are connected in a series or we can say in a line. So students, we will calculate the resistance offered by these three bulbs in the series circuit. Note down on your notebooks as well. So what will be the resistance? Now here we have see that the voltage across these three bulbs is going to be divided here. This voltage will provide voltage that will be divided into V1, V2 and V3, and these three bulbs will offer three resistances. How? This bulb will offer resistance R1, this will offer R2 and this will offer R3. So have you heard about the Ohm's law formula? Anyone of you? Yes?
V is equals to IR.
Yes, very good. The Ohm's law states that V is equal to IR. And here we have saw that the voltage is going to be divided. So we can write equation as V is equal to V1 plus V2 plus V3. Put it equation as 2. Now from this equation we will put the values over here. So any one of you stand up and just fill the values. Just stand up. Any one of you. What is the value of V here? V is equal to?
V1.
In equation 1, V is equal to? You have to see here. V is equal to IR. Very good. Sit down. So V is equal to IR. So V1 will become IR1 because V1 is going to be offered by the resistance R1. So V2 will become IR2 and V3 will become IR3. Can you tell me why I have not put 1, 2 and 3 over the current here?
Because current remains the same.
Yes, very good. But just don't give me the collective answer. Just raise your hands. Why we have not put? Yes.
Because the current remains the same.
Yes, very good. Because the current is going to be remain same here. So I have not put 1, 2 and 3 over the current values. So here IR. From this equation I can common out R1 plus R2 plus R3. Here I can be cancelled out with the I because left hand side is equal to the right hand side. So I can be cut out with the I. Now what we have left with? R is equal to R1 plus R2 plus R3. This is the resistance offered in the series circuit by the bulbs. Here the bulbs were combined in a line. Resistance is also come in a line. We can say the resistance also come in the combination of the resistances. Here we can put RS because we have done the resistance of series circuit. So we can write it as RS is equal to R1 plus R2 plus R3. So this is the resistance offered by the series circuit. Now I will show a flashcard in front of you. Then you have to identify what that flashcard represents. What does this flashcard represent? Just raise your hands. Yes?
Christmas lights.
Yes, very good. Christmas lights. Now students, can you tell me if one Christmas light is going to be burned, then whole circuit burns or not?
Yes.
Yes. So that type of circuit is known as a series circuit. In the Christmas lights, there the combination of the lights or resistances is equal to is in the series circuit. So this is the example or application of series circuit. Now we will do about the next combination, that is parallel combination. So now students, we have done with the series combination. Now we will do about the second combination, that is parallel combination. For that I will show you the model of that parallel circuit, which is this. And now in parallel circuits we will study about the resistance, that how the resistance is going to be find here. We will do derivation in the parallel circuit also. Now students, here you can see the 3 bulbs are connected parallelly, one by one. Now when we switch on the button, the current will start flowing through the battery. This will go through this and come here. Now at this common point, the current will think to what path he should go. So the current has divided into 3 parts, that is I1, I2 and I3, because there are the 3 paths for the current to be flow. So I1 plus I2 plus I3. Then again the I current will go to the battery, again the circuit will glow. Now when I switch on the button here, the bulbs start to glow simultaneously, not one by one. So in this circuit, the bulbs start to glow simultaneously and the current is going to be divided into 3 parts, that are I1 plus I2 plus I3. So students, note down on your notebooks that here in this combination, which value is varying? Which value is changeable here?
Current.
Current. Very good. So current is going to be divided into I1 plus I2 and plus I3. We can put it as equation number 1. Now we know about the Ohm's law, as we have done previously also. Applying Ohm's law, that was V is equal to IR. Now we will put second equation value in equation 1. Now students, can we define current from here? What will be that? Yes, Sumit?
I is equals to V upon R.
Yes, very good. I will become V divided by R. So from equation 1, current will be equals to V over R1. Is it correct? R1 is equal to V over R1. Why? Because in this circuit, the voltage is going to be remain same and the current is going to be divided. So I1 is equal to V over R1. Similarly, I2 will become V over R2 and I3 will become V over R3. Now put these 3 values of current in equation number 1 and then just tell me what is the value of resistance here. You all have to calculate. What is the value of current? So current will be equals to V over R1 plus V over R2 plus V over R3. I is equal to V upon R. So now students, we can see, we can common out V value here. So it will become 1 by R1, 1 by R2 plus 1 over R3. Cancel out the value V. So we will get I over 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now we have calculated resistance in parallel circuit. So we will put P here, which will represent resistance in parallel combination. So it is 1 over R1 plus 1 over R2 plus 1 over R3. Now students, can you compare both the circuit resistances with each other? In the previous series circuit, we have done R is equal to R1 plus R2 plus R3. But in this circuit, we have calculated 1 over R1. So which value is bigger than?
Series circuit.
In series combination, the resistance value is increasable, or we can say is bigger than in parallel combination. Now we will do an application. What does this flashcard represents?
Street light.
What?
Street light.
Street lights. So these street lights are combined in a parallel circuit, because if one street light is going to be burned, the another one remains same. They are not changeable. So these types of circuits are known as parallel circuits. Now students, we will do the comparison between both the circuits with the help of a chart. So students, observe carefully. Here is the comparison between the components of series and parallel circuits. Now in series circuit the flow of current was same, so here is same. But in parallel circuit that was different. As you have seen here. The current value has been changed and different. And the components were arranged in arrangement in a line. In a series combination, the resistances were combined in a line, and in the parallel circuit, they are parallel to each other. And next one is voltage. In the series combination, the voltage was different, but in the parallel circuit, the voltage was same. And now, what is the function? If one component breaks down, the whole circuit will burn out. As you have seen in the Christmas lights, if one circuit or if one bulb burns out, the whole circuit will burn out. But in the parallel combination, there is no effect on the other bulbs. Then here is the total voltage. The total voltage in the series combination was V1 plus V2 plus V3. But in the parallel combination, it is equal. In parallel combination, the voltage will remain equal. Then examples, as we have done the applications. So examples of the series combination are lamps, bulb, flashlights. And the examples of parallel combination, home wiring, microwave or machine, washing machine. So these are the applications of the series and the parallel circuit. Now students, we will recapitulate the lesson which we have discussed. Is everything clear to everyone?
Yes, ma'am.
Okay. So we will now recapitulate the lesson. I will ask few questions. If you know the answer, just raise your hand. Don't give me collective answers. Got it?
Yes, ma'am.
Okay. So students, just raise your hands only. In which circuit the resistance value was lesser? Yes.
In parallel circuit, the resistance value was less.
Yes, very good. In the parallel circuit, the resistance value was lesser than in the series circuit. In how many ways we can combine the resistance? Yes.
2 ways.
In which ways?
Series and parallel.
Very good. In series and parallel combination, we can connect the resistances. So, this is all about our lesson. Now, note down the homework on your notebooks. Write down the 5 applications of series and parallel combinations from your daily life in your notebooks. Clear to everyone?
Yes, ma'am.
Yes,
Okay,
ma'am.
thank you.